Manager here at Digi-Key, and today we are hanging out with CUI's Jeff Smoot, Vice President of Motion Control, to discuss CUI's AMT modular encoders that are featured on digikey.com/AMT, which includes an overview of the features and benefits that make this line of rugged, high-accuracy modular encoders unique. Jeff will also be discussing types of rotary encoders, applications, design challenges, and how a capacitive encoder works. As a reminder, we will be answering your questions at the end of the Hangout, and you can tweet any questions you have during the Hangout on Twitter with the hashtag DKHOA. Now let's head out to Jeff Smoot at CUI Inc. headquarters in Tualatin, Oregon.
Thanks, Pete. Thank you for having me today, and definitely appreciate the opportunity to talk a little bit about encoders and our AMT encoder series. So let me get the slides pulled up here. All right. So to start off, we'll just talk about what is an encoder. Most people tuning in probably know what an encoder is, so I'll just go over that a little bit quickly. But an encoder is really something that goes onto a generally on the back of a motor or on any shaft that rotates, and it's going to provide information on location, position data, speed, distance, direction. Provides a lot of feedback into the system for where that motor is in the rotation. Or where that shaft is in the rotation, that can go back into an overall system for any automation applications or just any application where there is rotary motion and where you need to know exactly where that shaft is or where you are in motion. So encoders, where are they used? They're really used all over the place. They're used industrial, medical applications, safety and security, test and measurement, consumer products, robotics, renewable energy, and then certainly, as I mentioned before, many automation applications. So it's really anywhere where you've got a motor and it's spinning, and you need to know where that motor is in its rotation. There's most likely an encoder there, or some other form of feedback device to know where you are, but certainly the most common is the encoder. So there's several types of encoders, but the three main types of encoders are optical, capacitive, and magnetic. And with the optical encoder, that has some LEDs in there and a rotary disc. That has different windows in there, and it allows the light to pass through that disc as the rotor turns and interprets that and gives that back as feedback. Then you've got a magnetic that works on the same principles, but the disc has individual magnetic elements in there. And then we've got capacitive, which we'll talk about a little bit later. But these are the three main types of encoders out there. On the market, there are some other outliers there, but these are really what dominates the market. So with that, and with these three different types, there's design challenges that can kind of make going one direction or the other with the type of technology that you use. So some of the design challenges facing the motion control engineer out there when using an encoder and selecting an encoder, one of the biggest ones is dust, dirt, and oil. So motors are going in most of the time some pretty dusty, dirty, bad environments where not necessarily your most clean places that they're asked to operate. And so with that, obviously you get a lot of contaminants in the area, and that can affect encoder performance, and it definitely is a challenge for encoders, and that's certainly becomes a challenge for an optical encoder, where some of the other encoders work well in that environment. The optical has a challenge because of line of sight. obviously. And then other issues, certainly oil with for lubrication in the motion environment. But then there's also applications where the entire enclosure has to be submerged in oil, and those obviously pose some real challenges to the designer and in where they're using that encoder. Next on the list is durability. Again, these are oftentimes motors that are spinning at a fairly high RPM, but they can be used in lots of applications where temperature's a concern. One, you get a lot of heat from the motor, and the encoder is mounted right up against the motor, so you get a lot of heat coming in through the enclosure to the encoder. Not to mention when it's going into applications that may be asked to operate in elevated temperatures, and so that combination can be a real challenge for the designer. The other thing the designer has to consider is vibration. How much vibration is there going to be in the system where this encoder is intended to be used? Is this going to be something where there's going to be high impacts as the motor goes around, or long-term vibration at a specific frequency, or random vibration, or if it's going to be sitting still on more of a desktop application? But that has to be considered, because there's trade-offs there. And then certainly lifespan. Anytime that you're designing something, you want to make sure that it's going to fulfill the lifespan, the intended lifespan for the device, so that it doesn't you don't have parts breaking before it's needed. And it's certainly a concern with choosing the type of encoder technology that the designer uses as well. So some more design challenges. Installation. So you have to get there are options where you can put feedback devices inside a motor. There's some trade-offs with that, but when using an encoder, you have to get that installed onto the motor. And that can be some very serious challenges in the installation, particularly when installing on a brushless DC motor. That can be a quite time-consuming process in the assembly process, and obviously the more time that you're spending in assembly, time is money, and if the installation is difficult, it can add to the overall cost, even though you don't necessarily see it in piece price. Next option is versatility, and versatility is definitely a necessary part when you're looking at your design. For one, in the R&D phase of how much versatility you can have with a product, for being able to make changes as designs change throughout the evolution of the design. But also from a larger scale, if you look at if you just look at stocking, what you're able to stock and have, if you're using encoders in several different applications, either within one product or within several products that your company has. Being able to have the versatility of, well, how many items do I have on the shelf, and that's something that isn't maybe necessarily readily apparent to the designer as they're working on the specific design, but is a larger concern, and something that can be have an impact on the choice of encoder. The next area is just with the PID loop control. Certainly, when you're in the design, you're optimizing. Being able to really optimize that PID loop. Sometimes you have to change resolutions from what the original design intent was, and so being able to optimize and change resolutions is an important part in optimizing design. And then finally is current consumption. As more and more products are going to mobile, battery operated, and that's been just certainly in the last 10 years, that is skyrocketed and just grown exponentially, the amount of mobile applications out there. Current consumption becomes a big deal. And you're looking at battery life, and everyone's driving to extend that battery life. And so battery life is definitely tied to how much current you're drawing. And so you have to look at current consumption in the design. And so There's probably a couple other ones in there that I didn't highlight, but these are some of the major design challenges. And so when CUI came out with our capacitive encoder, it was really to target these design challenges that I just talked with you about. And so to give a brief overview of how a capacitive encoder works and what a capacitive encoder is, this is, you can see there on the slide, just kind of a breakout of what's going on inside the encoder. And from a high level, we have a transmitter board, a rotor board, and a receiver board. And the transmitter board sends a signal that the rotor board, as the shaft spins, interrupts that signal with the sinusoidal pattern you see there on the rotor. It gets interpreted by the receiver, sent back up to our proprietary ASIC on the transmitter board, and then that gets sent out as the information down to the customer on where the position of the encoder is. So some of the benefits and why we went with that capacitive encoder was to really be able to bridge the gap between magnetic and optical encoders, because as you look at some of those design challenges, to meet some of those, you one, get driven to a optical encoder or driven to a magnetic encoder, depending on what those design challenges are. And what we've tried to do with the capacitive encoder is try to be the best of both worlds. So you get the performance in all the environments, and you don't have to make sacrifices or design trade-offs. And so with the capacitive encoder, it's rugged, it's not susceptible to the airborne contaminants. So in your dusty, dirty environment, it doesn't have a problem where an optical can. It has higher operating temperature, which is an advantage over a magnetic encoder. No LEDs to fail. When we look at lifespan, that's a concern for opticals. Far less susceptible to vibration, also, as you look at opticals. Next, then there's cost. We really looked at that assembly time and how much time it is to assemble the encoder onto the motor, and we'll talk about that a little bit more in a few slides. And then just the overall price. Wanted to be price competitive with it. And then finally, as we talked about, just the current consumption and accuracy. So wanted to go for as low current consumption as possible, but then also having the high accuracy that sometimes when you select a magnetic encoder to go into maybe an oily or dirty environment over an optical, you sacrifice some of the accuracy, and that we're able to work in those environments because of the capacitive technology, yet still have the high accuracy. So what CUI has in our capacitive encoders is we've got some incremental or quadrature encoders, absolute and commutation. We've got our AMT 10 and 11 series on the incremental quadrature. We've got our AMT 20 on the absolute, and then our AMT 31 on the commutation. So with as mentioned, versatility. One of the main features we tried to offer was versatility. And with one package that you can buy from Digi-Key, we're able to fit 9 different sleeves. We have up to 20 different selectable resolutions and many different mounting patterns, all in one SKU that you're able to get from Digi-Key. And so we offer a lot of versatility to the customer. With, you can stock one item and be able to adapt to either multiple designs or design changes. As we mentioned, assembly is a big portion. The assembly of the AMT is very simple. The base gets added, the sleeve and shaft adapter you see there get pressed on, and then the top cover just snaps into place. A very simple installation where you only really need a screwdriver, and you don't need a whole lot of extra tools to do that. We've really tried to simplify the assembly process, particularly over an optical, where you have to be very careful not to get any contaminants on that optical disc. So just a quick overview of our AMT 10 series. As I mentioned, we've got the 9 mounting patterns, the 9 different shaft adapters for your shaft diameters. We have 2 different versions for horizontal or vertical orientation of the connector, and then we have the 16 selectable resolutions that you're able to change on the fly with a dip switch there on the encoder. So as you're doing that optimization in your design of that PID loop, and you need to adjust resolutions, you can just adjust that quickly with the dip switch. Whereas if you were with a magnetic or an optical solution, you'd have to go purchase a different encoder, wait for that to arrive, assemble that onto the encoder, and you're down a day or two. Where with an AMT, you're down a minute because you're able to easily adjust the resolution with that dip switch. It also offers versatility with being able to stock one item, and then you can just change the resolution depending on which part of the design it goes into. So our next series to highlight is our MT20. That's an absolute encoder. Won't go into that too much here on this talk, but an absolute encoder is we have those same advantages there, and that is a different type of encoder that is really becoming more and more prominent in applications where you don't want to do a homing sequence, or you need to know exactly where you are when you start up. So we offer a absolute encoder in our capacitive technology in that AMT20 series. And then I'd like to talk about some of the new encoders that we've either come out with or coming out with. So we've got our AMT11 series, which is a incremental quadrature encoder that we released in May. And then we've got our AMT31, which is a commutation encoder for brushless DC motors that we'll be releasing in September. So with our AMT11, it's really the next generation from our AMT10. We've added more selectable resolutions. We brought a line driver on board and a selectable capacitive index there. So some of the advantages, we talked about the more resolutions, the higher resolutions. We have higher accuracy with that. But one of the things I really want to highlight on this one is the GUI programmability on this. We're able to connect the encoder to our GUI, and able to go in and adjust the encoder resolution, adjust different parameters, and really use it as a design tool that you can adjust right there on the fly. So you don't have to worry about doing a dip switch, and you can just adjust and program it right there on the fly, and offer some really good capabilities. The other cool feature is some onboard diagnostics. Because we are ASIC and microcontroller based, we're able to offer diagnostics that you can use our GUI to be able to see that one, yep, the encoder is in good working condition, or no, the encoder has failed for one reason or another, or you might have a mounting problem. And we've got onboard diagnostics. We're able to give the designer and the customer that tool in their hand to be able to get that data. So our AMT31, which is our commutation encoder, it's designed for brushless DC motors to be able to provide the UVW commutation signals. We're able to work with 2, 4, 6, 8, 10, 12, and 20 pole count motors. We have the 20 incremental options that are also available on that. And then we'll talk a little bit about the programmable one touch, which really vastly improves the assembly time with a brushless DC motor. Just quickly, some of the advantages, very similar to what we saw with the AMT11, with the GUI programmable, the onboard diagnostics, and extended temperature range. But I really want to talk about our One Touch Zero. And because we're microchip or microcontroller and ASIC based, we're able to set the zero position of our encoder on a brushless DC motor in a matter of 1 to 2 minutes versus 10 to 15 minutes if you're doing that with an optical encoder. And so without going into too much detail on what that all entails, this is a major time savings, and certainly if there's any questions, I'd be happy to address that here in the talk. But the One Touch Zero is something where you can either do it through the GUI or with our One Touch Zero board that we have, and really with the push of the one button there, you see you align the encoder correctly with the windings on the brushless DC motor, and it really eliminates the need for back EMF in a process, and can pull significant time out of the manufacturing and assembly process when putting this onto a motor. So purchasing these units are all or will all when the AMT31 is released be available at Digi-Key and on the shelf. We have great kits that work well in the design process, where you get the AMT encoder, you get those shaft adapters, the sleeves, all tools you need come with it, and then the different bases. So that is kind of a quick summary. Hopefully that was able to be a little enlightening on some of the different encoder technologies, the design challenges when choosing a technology, and then highlighting where the capacitive encoder and CUI's AMT series of encoders can help the designer really address those challenges.
Thank you, Jeff. Appreciate you covering the benefits and the features and the challenges. One of the things that you mentioned was the benefits of the AMT modular series versus the optical. And one question we have is, will I need to make changes to my system in order to switch from an optical to a capacitive encoder?
So that's one nice thing. You don't have to make changes to your system to switch from an optical to a capacitive, or from a magnetic to a capacitive. The way the signals are generated are obviously different, but what we output from a capacitive encoder is the same output that you're going to get from an optical. So with an incremental, it's going to be your quadratary, your A, B, and an index pulse, your square waves coming out. Or with a commutation, you're going to be still getting your UVW signals that are the same from a magnetic, an optical, or a capacitive. So it's very easy to be able to bring that in. You don't have to make any massive changes to your system.
Great, thank you, Jeff. Last question we have is how do you mount? I think you might have covered this in your presentation, but maybe you can just review real quickly, about how an AMT encoder is mounted.
Yeah. Certainly, and yeah. So to mount an AMT encoder, we tried to make that very simple, and that was something we definitely targeted in the design. And so it's simply you take the base and you get that centered using our centering tool on the motor. Screw that into whatever pattern bolt pattern you have, and we have 9 different bolt patterns available. So we hit probably 99% of the bolt patterns out there with our existing bases. You screw that in place, and then you select the shaft adapter for your size. So it's the little colored shaft adapter that comes in the kit. You slide that on, it gets pressed into place with the tool, and then you simply take the encoder portion, the encoder housing, the top cover, and it just snaps into place. You don't have to do any precise aligning. You don't have to be careful not to get your hand on the optical disc. You don't have to bring in like a little hex nut to work with a little screw to get that clamped down onto the shaft. So it really does make installation very quickly. And then certainly with the brushless DC motor with our One Touch Zero, you don't have to go through a back EMF process once you've installed it onto the motor, where you have to bring out a scope and additional power supplies and take it over to your back EMF fixture. You can just send it, use the One Touch Zero board, or use the GUI to align the encoder with the windings, and you're off and going and saving yourself 10 to 15 minutes easily.
Great. Thank you, Jeff. I think that's all we have for questions today. Thank you, everybody, for joining us, and have a great day.
Thanks, Pete.
Yep, thank you.